Hello, let's take a look at question 4, and we start from part A. So first, note that the data is standardized, so we know each component. So for each variable xj, we know that they have zero mean, which leads to this conclusion that for both z1 and z2, they also have zero mean. And an implication is that if you look at this form, so the object that's analyzed in claim A, on the left-hand side, it's the sum from 1 to 50, j from 1 to 5, alpha 1j x 1j. So squared. You can also add -0, so this doesn't change everything, but in fact, -0 is a mean of z1. So this term here, if it's divided by 50 minus 1, then it's the variance of z1. So it's empirical variance based on the 50 observations of z1. Basically, the transformed version of x1 up until x5. So according to the weights stated in the question. And similarly for the other term on the right-hand side, that is the sum from 1 to 50, 1 to 5, alpha 2j, xij. Of course, we can add this, add a -0 term, which doesn't affect anything. But now we know the mean of z2 is also 0. So this, in fact, if it's again multiplied by 50 minus 1, then this gives the sample variance of z2. So basically, this claim is asking you to compare these two terms. And the calculation of variance for both terms are similar. So let's just take a look at z1 first. The point here is you need to remember that we also need to take into account the covariance term. So the expression for the variance of z1 is first from 1 up until 5, alpha 1j squared times the variance of xj, but also plus 2 times, sorry, 2 times, let's see, j from 1 to 5. Okay, let me write it this way. So remember the equation j from 1 to 5, j prime from 1 to 5, j prime doesn't equal to j, alpha 1j times alpha 1j prime times the covariance of xj prime. The thing is, for the first term here, we know that the data is standardized, so this is equal to 1, and the sum of this term is equal to j from 1 to 5, alpha 1j squared, which is equal to 1 because the norm of vector alpha 1 is 1. However, we have no idea what's the covariance term. This information is not provided at all, which means this will be equal to 1 plus a term that we can't really, we don't really know how to evaluate because we have no information about it, about the covariance term. So j1, j prime doesn't equal to, sorry, j prime equals 1 to 5, but j prime doesn't equal to j, alpha 1j, alpha 1j prime, covariance xj prime. So it's the same here for Z2, you will also get it's equal to 1 plus a term that we don't really know how to evaluate because of the lack of information about the covariance structure. Alpha 2J prime covariance Xj prime. So in short, for claim A, we know that we can't really compare these two terms because of the lack of information. So in general, A is not true. And similarly for claim D, we have done the calculation already, right? Like we know it's 1 plus a certain term. So variance of D1 is 1 plus this term here, but we can't really evaluate the remaining term. So in general, claim D is also not true. Yeah, the point here, at least for claims A and D, is to remember that in the equation, in the expression for variance, you need to know the covariance structure of the component in the summation. Cool, let's move on to part B, claim B. And this claim here is J1 up until 5, alpha 1J, alpha 2J is equal to the dot product of the vector alpha 1 and alpha 2. And this equals 0. It means that alpha 1 and alpha 2 are orthogonal. So now we see this would be a useful assumption because then it means after the transformation, the Z1, Z2 variables we obtain, they should also be orthogonal. So we are transforming these variables, say x1 upon x5, that are potentially having correlations and covariance structures into some variables that are orthogonal. All right, the last claim here is part C. So remember that J1, this summation is alpha 1J squared and alpha 2J squared. So note that the so-called norm, we know that the norm of each of these vectors is 1, and the definition of norm is this. So it's a sum of the squared coordinates, but we also take the square root of it. So if this is equal to 1, it means the summation of the J1, 5, alpha 1 J squared is 1. The summation of, because for alpha 2, vector alpha 2, we know its norm is also 1. So we have this. Then it means this term is equal to 1. This summation equals 1 as well. So the total would be 2 instead of 1. In other words, claim C is also not true.